section 5. I'm going to do this warm-up for y'all just because this was a problem on that test. How do I get rid of the exponent 2/3? Do the 3/2, right? Take the reciprocal power. So I take both sides to the 3/2. So that's going to cancel that out. You get x. And what's 4 to the 3/2? So that means the 2 needs to take the square root, which is 2, and cube it. Say, do I need a plus or minus?
Mm-hmm. Yeah.
Yes, because I have an even numerator. Okay? All right, so that's all I got. All right, this next one, I gotta straighten this out, whether I like it or not. All right. All right, this next one, what kind of equation is that?
I don't know, but you squared.
Exponential, right? Good. So we have to write 9 as 3 squared, right? So whoever said that was right. So I have 3 to the x minus 3 is 3 squared. I saw people on this test like try to divide the 3's out or something. You can't do that, right? You just make the bases the same and then they go away, all right? So they cancel, and I get x minus 3 equals 2. So you get x equals 5, okay? That hopefully should feel comfortable for you. All right, so today we're going to work more with log rules, all right? We're going to go back over them, and just, it's nothing new. We're just practicing with the log rules. All right, actually we're going to solve exponential with logs. All right, so we've already seen one type of exponential equation. When the bases are the same, like I have 3 to the x equals 3 to the, something like that you can solve because you can make the bases the same. If I can do that, I'll usually do it. It's easier than dealing with logs, okay? Method 2, if I don't have a common base, I'm going to rewrite the equation with one term on each side. So I'm going to have something like 2 to the x equals 3. And then I'm going to take the natural log or the common log. Actually, because we have this log base on a calculator, I can use a calculator. So I would take log base, I would just write it as a log. So how would I write this in log form? Log base what? 2 of 3 equals x. And this is something I can plug in my calculator, okay? But today, of course, we don't have a calculator, so we're just going to leave it like that and assume we could, okay? All right? All right, and power functions are totally different, right? That's where I have the x in the base, not in the exponent, okay? All right. So we're going to do some practice with logs, and and I put the log rules here in the corner so you could kind of look at them. We need to know those rules, right? All right, so look at number 1, and this is the process I go through. The first question I ask myself is, can I write them as powers of the same number? Yeah, so that's how I'm going to solve that, right? This is what we did in the last unit. So I have 3 to the x plus 1. 81 is 3 to what power? 4. So now I can cancel the 3's, and I have x plus 1 equals 4. Is that right? And you subtract your 1, and you get x is 3. So if you can write them as powers of the same base, that's easy to do so, and you should do so. Okay? Now I want you to look at number 2 there. Do I have powers of the same base? No. Okay, so this tells me what I'm going to be doing is using a log. All right? If you use a log, you're going to get the exponent part alone. Okay, that was something you guys struggled with on your test, and I remember. It means I have to get rid of the 8. I have to get 3 to the x alone. So how do I get rid of the 8? Divide by. So I'm going to divide both sides by 8. So what I end up with is 3 to the x equals 5/8. And once I have the exponent alone, then I can take the log. Okay? So write this in log form. So it'd be log base what? 3 of 5/8 equals x. And again, that's something I can just type in a calculator. Okay? With the log base thing. Is that right? Okay. Now just to mention to you, some people will actually do it this way, just so that if you ever see it, wouldn't surprise you. If I have 3 to the x equals 5/8, I don't have to do log base 3. I can take the ln or the log of both sides. It doesn't matter. I like ln. Since ln's my favorite. All right, so if I take the log of both sides, I'm allowed to do that, right? What I do to one side, I do to the other. Yes? And using a log rule, can I get that x out of the exponent? Which log rule could I use here to get that x up downstairs? 1, 2, 3, 4, 5. 5, right? Because the log of something to the k is k times the log, right? So I can take this downstairs and make it x ln of 3 equals the ln of 5/8, right? And this is just a number. Ln of 3 is just a number, so you just get rid of it by dividing by it, right? So I get x is the ln of 5/8 divided by the ln of 3. And again, that's something I can type in my calculator, all right? And that is the same as log base 3 of 5/8 because that was that change of base we talked about just yesterday, okay? All right, so those two are the same. All right, now this is probably the hardest type. You know what makes it hard? Number 3? If you look at it, there are exponents on both sides and powers that can't be made the same, right? Yes? So there's a couple ways to go about this. I generally just like to take the log of both sides, the ln, okay? So if I take the ln of 2 to the x, that's going to equal the ln of 5 to the x minus 1. Is that all right? ln of 2 to the x, not 2x. I didn't write that right. Okay? So what that's going to do is allow me to take those exponents downstairs. All right? So the x comes downstairs. So I have x ln 2 equals x minus 1 times the ln of 5. Is that all right? Now, normally at this point, I'd be plugging these in the calculator. I don't have a calculator today, so we're going to work with them as if they were numbers. All right. I'm not going to distribute. I'm going to divide both sides by the ln of 5. So I get x times the ln 2 over the ln of 5 equals x minus 1. Is that all right? So what do I have to do next to get? I have to get my x's together. So what am I going to do? You're going to move your x over, right? So what I have, I have x times the ln of 2 over the ln of 5. Again, it's just a number. Minus x equals 1. I just move the x over, right? Then factor it out. Okay, so I'm going to move this. This is in the way. Huh?
Why can't you do the minus plus 1?
Why can't I? Just what?
Plus 1?
Well, you got to get the x's on the same side, right?
Would it be a negative 1?
Oh, it is a negative 1. You got me. Okay, I'm going to move this out of the way. I'm going to change that. All right, so that's a negative 1. Yes? All right, so you factor out the x. So it's the ln of 2 over the ln of 5 minus 1 equals negative 1. So how do I get rid of the stuff multiplying x?
Wait, where did you get
No, it's minus x.
What?
It's minus
Inside.
No, I factored the x out. Right, look, I have an x here and an x here.
So it just goes away?
I divided by x, right? How do you, when you factor, you divide by x?
Oh, well, you didn't show that stuff.
Well, okay, that's, you know how to do that. That's how they want. All right, we good? Okay, everybody understand how I did that now? A lot of people will make that a 0. It's not, right? You need something after the negative. You can't just take that negative away. All right, so, okay, so I get x is going to be negative 1 over all that mess, right? We'll say this. All right. Normally, at this point, I would have been typing this stuff in the calculator way up here. Unfortunately, I don't have a calculator today. All right, we good? I can take algebra 1 for that. All right, good? All right, that's the hardest type of log equation. We'll work some more with those, okay? So take the log of both sides. So what taking the log does, I want you to understand what taking the log does. It takes the x out of the exponent down and down out front, which makes it something I can deal with, okay? All right. So if I want to solve e to the x equals 30, this is a very easy equation. I'm going to write it as a log, right? The exponential is already alone. So how would I write it as a log? What's the opposite of e? ln. So I'd say the ln of 30 equals x, and that's just a number that I can type in my calculator. Okay? Easy one?
We don't have that on.
I know, there's some of these you don't have on your notes because your notes were a little sketchy. Okay? So take your own notes for a little while. Okay? I'm doing this for a reason. All right, so what would I do on this equation? I am going to pull out a calculator. I've got one, so you have to excuse me that that's all I got. So then this is bad enough that I'm going to pull a calculator out. All right. What would I do here? I have to isolate the exponent, so what's the first thing you're going to do? Divide by 150, right? Before you pull it down, get the exponent alone. Okay? So I'm going to divide by 150. So I have e to the 0.05x. I'm going to do that on a calculator because I'm at a point where I have to. All right, so 340 divided by 150 is 2.267. All right. And now I'm going to write it as a log. Once I have the exponent alone, I write it as a log. So what's my ln? I already told you. I'm going to use the ln, right? So the ln of 2.267, right, equals 0.05x, right? Okay. So and an ln of 2.267 is just a number. So I'm going to press it on my calculator, right? So ln. Find my ln button, third one up from the left. And I get 0.818 equals 0.05x, and now I just divide by 0.05 and I'm in business, right? 0.818 divided by 0.05. That's 16.6. Okay? So the whole idea with this is when you do not have like bases, you're going to have to take a log in one form or another. Okay? I had you last unit solving these on a calculator by plugging them in y1 and y2 and find the intersection, but it's a lot quicker, I think, to use just a log and solve it. Okay. All right, and that's the whole point of logs. All right, so you guys tell me, what would I do first with this equation? The 2 over, right? You have to isolate the exponent, right? So I have 4 to the x plus 2 equals 14. All right. So now I'm going to write it as a log. All right, so tell me how to write it as a log. Log base 4 of 14 x plus 2. All right, now that is just a number, and you're just going to subtract 2. Do you mind if I do it on my calculator using log base? All right, so log base is alpha window number 5. Log base 4 of 14 is 1.90367. 68 equals x plus 2. So the next thing I just need to do is subtract 2 on there. So
Could
my
you just
calculator.
subtract?
Huh?
Could you just subtract like 2? Or you can't?
Yeah, you could certainly write this as log base 4 of 14, right, minus 2. You do not want to make it the log of 12, right, because that's not in the log there. Okay? Does that make sense? All right. And you're going to get negative 0.0963. Okay? Is that right? So the whole point of these exponential equations is you get the exponent alone, then you write it as a log and just solve it the way you know how using algebra. Okay? All right, this one looks straight scary, right? Okay. I want you to think about what it is we really have here. This is just some advanced factoring. Because e to the 2x, is that not like x, e to the x squared? That's the same thing. Minus 4 times e to the x plus 3. Does that look like something you know when I write it that way? Should look like something you know. Right, it's a quadratic. Yeah? So what I'm going to do, the best thing to do is just do a substitution. Let u be e to the x. So what you have is u squared minus 4u plus 3 equals 0. And that's something you can deal with, right? You can factor it. How does it factor? Factors of 3 that add to negative 4.
4 minus 1.
Negative 3 and negative 1, right? Is that right? So it's u u minus 3 times u minus 1 equals 0. So I get u equals 3 or u equals 1, right? But u is not u. I'm going to plug back in e to the x. So I get e to the x equals 3 or e to the x equals 1. Now I got to solve for x. All right, so how do I solve for x? How do I get rid of e? ln, right? So the ln of, guess which one it is? Ln of 3, right, equals x, which is just a number, right? And the other one would be the ln of 1 equals x. By the way, what's the ln of 1? You know that? What's the ln of 0, right? The log of 1 is always 0. Go to calculus, know that, and make the calculus figure happen. Okay? All right. We good? All right. See how I had to do a few more equations because the notes were kind of sketchy. All right. Is that it? Oh, is this notes or is this just extra equations? That's notes? Okay, let's go back to notes and finish it. All right. So you guys tell me, now that we've done some more equations, what would I do first on this? Divide by 600. Huh? Oh, by 500, yeah. Is it all right if I just write 6/5? That's what you're going to get. Okay. And so how do I get rid of e? So it's the ln of 6/5 equals 0.3x. And again, the ln of 6/5 is just a number, so I type it in my calculator, right? That's all I'm going to do. ln of 6/5 on my calculator is 0.1823. And that is 0.3x. So now my last step is to just divide by 0.3. And get x is 0.608. Okay? So you can solve exponential equations with logs. Now look at number 5. Is that an exponential equation? No, it's a power function, right? So I need to isolate the powers. So what do I do first? Multiply by 2. So I get x to the 1/3 minus 5 equals 14. All right, that's multiplied by 2 on each side. All right, and then what? Add 5. So x to the 1/3 is 19. This is not an x. This is not something I take a log with, right? How do I get rid of the 1/3? 3. Cube it, right? So good. So I cube it. So x would be 19 cubed, whatever the heck that number is. I'll move here. It's a big number. Okay? Big number. All right? All right. So there's that whole idea with this, with exponential equations. We're not going to do the practice, so I want to record the next lesson. So we good with this? Yeah. Okay. And but just take a log to get rid of it. All right? All right. Let me ask you. Would I take a log with number 1 here? No, it's power, right? Would I take a log with number 2?
Yeah.
I could, but I wouldn't, because these are powers of 3, so I don't need to. Okay? But just to kind of remind you that sometimes you can do that. How about number 3? Would I take a log? Yeah. Okay. Number 4? Yeah. Okay. All right. So that's some practice with equations. And I think day 6 is where we get into just practice with logs. So I'm going to stop that recording.